Hello, welcome back to Cracking the Cryptic, and it's a joy to have you join us for some variant Sudoku fun. We do 2 videos a day, one by me, one by Simon, and we stream on Mondays and do a crossword cryptic masterclass on Fridays. And we do Wordle in a minute and minute cryptic every day as well, just trying to bring you loads of puzzle content as always. And of course on Patreon we have even more with crosswords, occasionally gridogram and connections videos, as well as a Sudoku hunt each month and solution videos to that. So do check it out. There's lots of extra stuff on Patreon. We love it if people join us there. And of course, there's all of our apps, which include Line Sudoku, Killer Sudoku, what else is relevant to today? Domino Sudoku, Classic Sudoku 2, and the Worms by the luminaries like Blobz. Do check those out. They are great fun. Now, today's puzzle is by Joran, who has not featured on the channel before, so a debut. Welcome, Joran. Maybe it's Uren. I don't know how to pronounce this. The puzzle is called Half and Half. I know how to pronounce that. And I'm going to go through the rules, and you can try it on the first link under the video to play it in our software. And before you do that, remember to subscribe to the channel if you haven't already done it. Let's have a look at the rules. Normal Sudoku rules apply. That means 1 to 9 will have to go into every row, column, and 3 by 3 box. Now, orthogonally adjacent cells may not contain consecutive digits. So any 2 cells touching each other at a whole edge can't have consecutive digits. There's a global non-consecutive constraint. They're quite difficult to use early on normally. They're very helpful later on in puzzles. And therefore they need to be remembered for later sometimes. Digits along a grey line must be between the digits in the attached circles. So if we had a 3 and a 7 there, all of these digits would have to be 4, 5 or 6. You could have repeats. Digits cannot repeat inside a cage. I think these cages are both 9 cells big, so they contain each of the digits once. Cells on a black dot, one of the digits must be double the other. So those are the rules. Remember that non-consecutive constraint. It's going to be important, no doubt at all. Let's get cracking and see how we do. So I'm just thinking about the black dots first of all. And I'm going to say this, none of them contain a 1-2 pair, because that would break the non-consecutive constraint. So all the black dots, the digits used on them are 2, 4, 8, 3 and 6. And I say those in an order because I'm thinking of them as 2, 4, 8 family and a 3, 6 family. Because none of the 3, 6 digits can't join to any of the 2, 4, 8 digits and vice versa. This may not have been a very sensible way of marking up the puzzle to start with. Oh, no, it's very interesting here actually. Or is it? No, maybe it's not. This could be a 3-6-3-6 group. Yeah, that's really strange. I think it can be. I thought maybe the black dot was going to say that's impossible, but I don't think it does. Okay, I mean, here's another weird consideration. Let's call those the green cells that make up a black dot. Where do those digits go in this central plus shape? No, I mean, there's other weird considerations going on. Okay, but the answer to that, which I was looking at, is that they must go amongst these cells because they can't sit in these 5 in the same row. So here we have either double green. Well, I was going to say double green there or double green here, or not. or one of those greens here and one of them down here, which is annoyingly entirely possible. Now, I've got other things on my mind. So if I compare this shape with this box, so one of them I've coloured in violet and one in yellow, those digits are the numbers 1 to 9. For yellow, they're the digits 1 to 9. For violet, they're the digits 1 to 9. If I eliminate 7 of the same digits from each set, then these two yellows must be the same as these two violets. And one of those violets, therefore, is a digit from the 2, 3, 4, 6, 8 family. Oh, and I was going to say that now we've got all 4 in this row, but there are, you will have noticed, as I didn't, that there are 5 digits in the 2, 3, 4, 6, 8 family, which is an extended family that I've just made up. These 2 digits, similarly, must appear in these 2 cells. Does that mean that is the same as that? It seems very likely, but that's not a way to rule on the puzzle. I'm really not getting the idea of this yet, am I? This pair is on the line. If that was the 2, 4 pair, we would need to have a 1 in a circle, and it would have to be here. And then I don't know. Okay, here's another weird issue. Orange is the same as red. No, I'm going to deal with another issue now. This family of digits has to be different from this one, I think, in this puzzle. There are 3 digits that are in the same family, 2, 4, and 8. So one of these sets across a row could be 2, 4, and 8. But that couldn't apply with both sets, because you would end up with 3 4s. This black dot would have to have a 4 on. And these black dots would both have a 4 on, and that would be 3 4s for just 2 rows. That's not possible. So these are different families of digits. Gosh, I really don't understand how we're meant to look at this. There's a good way, and there's me struggling around. Anyway, I'm going to cling on to the bits I've got. So either this is 3, 6, 3, 6, and that includes a 4, or this is digits from 2, 4, 8, including 2 4s, and this is a 3, 6 pair. Right, if that was the case, this digit couldn't be 4, because that would fall in between the 3 and 6 on this line. So that digit couldn't be the 4, this digit would be the 4, and that digit would therefore be a 4 as well. So I think these 2 digits can't be 4s by that analysis. Now, if this was a 3, 6, 3, 6 black dot, does something else go wrong? There'd be a 4 here. I don't know. I don't know if anything does go wrong. There's something in the interplay between the lines. Also, yeah, there's another thought. We've got the non-consecutive rule. If this was 3, 6, the 3 couldn't sit next to 4. 4 would be there because of the between lines rule. So if this is a 3, 6 shape, 3 is not sitting down here next to 4. So if it's a 3, 6 shape, the 3 is here and the 6 is here. I don't know if that helps anything. It would stop this being a 2. So in fact, in the situation in which this is from the 2, 4, 8 family, that is not a 2. I mean, this is getting weirder by the moment. Okay, here's another point. This cannot be a 2-4 black dot, because both 2 and 4 would be sitting next to one of these cells, and they would be a 3-6 cell. So one of 2 or 4 would be sitting next to a 3. So if this uses a 4, it's a 4-8 pair. If it's a 4-8 pair, one of these circles, and it's this one, would have to contain a 9. And this would be 2 or 3. Well, it would be 3 very specifically. So this couldn't be 6 now. And therefore this digit can't be 6. And we've now reduced this down to 3 or 8. Okay, this can't be 4 anymore, because this would be from the 4-8 family, these would be from the 3-6 family, and 4 would be next to 3. So that's not 4. Now I've got a 3-8 pair sitting here. But this can't, oh, I was going to say, hang on, no, this can't be 8 now that the top one can't be 4. Okay, that wasn't it. But the 3-8 pair eliminates 3 or 8 from this cell. Actually, I can eliminate 3 from this one as well. This one's definitely even, so's that. I'm not looking at parity, because I've got so many other things to look at that would just confuse me. And I still don't know which family that is and which family this is. They are desperately trying to sit really close to each other, which makes me think this is the focus of the puzzle to get started. This is either 6 under 3 or 4 under 8. And if it's an 8, we go 8, 3, 6, 3, 6, 4. Okay, oh no, I was about to say this has to be the high-end circle, but that's not true. If this is 8, this could be the high-end circle. Then we're going 4, 4 here, and 6, 3 on the line. 4, 6, 3 on the line. This digit would be 1 or 2 for the between line rule. And this would be an 8, 4 pair. I don't know what that does to this cell, which must appear in one of the violets. Oh, this is so confusing. Right, how could this digit be in that red cell? Because if this is 3, this group needs that to be a 3. If this is 8, this group needs that to be an 8. So if it's 3 or 8, it's definitely there. If it's 2, it would have to be here. And then we'd have 4s in these cells and an 8 here. We'd have 2, 4, 8 sitting there. And a 3 here. I don't see that that's impossible. Oh, there's something going on in the plus, isn't there? What am I missing here? Or in the non-consecutive constraint somewhere that I'm just not seeing it yet. That's so confusing. Oh, I've just worked out that if you aggregate these 3 shapes versus the central 3 columns, that's 3 sets of the digits 1 to 9. And that means that these 2 that sit outside the shapes in the central boxes are the same as these 2. So in some order, they're yellow and orange. That probably is not going to help at all, even though, wow, what do we know here? We know that either this is 3, 6, 4. Does this have to be 4? Yes, this digit can't be 2 or 8. If this is the 2, 4, 6, 8 family, This is where the fours go. So neither of them can be 2. And this can't be 8. And that is now a 4-6 pair. Ah, that's so obvious. I hadn't seen it. Doesn't take a digit out of that cell. I'm sorry if I'm being so dense here. Oh, there's also, here's an additional or interesting problem. If that pair is 3, 6, this digit is an 8 in the box. And that makes this a 3, 6 black dot. So those greens would be these greens. Okay, I don't know what that does. But we know that this line, this between line, contains 4 and 6 on it, and either 3 or 8. So if it has an 8, that's a 9, and this is 2 or 3. If it has a 3 on it, one of these is 1 or 2. That's not helpful. That's just not interesting. Orange is the same as red. Yellow is the same as violet. I almost want to say that yellow can't be in the same family as this group, but I can't quite, because if they were 2, 4 and 8, these would be 4 and 8. One of these would be a 2 because it was there. And I might be missing the point still about those. So I don't know. It's so frustrating to have got this down to a pair and this down to a pair and not know how they operate still. Oh, goodness. Just bear with me while I try and figure out what we're doing. Where does this digit go in the central box? Because it's not... Is that interesting? No, I don't think it is. These are the same as each other. If they were 6s, that wouldn't be allowed to be a 6 because we'd have a mismatch between 3s there and there. So if these were 6s, this pair would have to be a 6-3 pair. And there'd definitely be a 4 on this. I don't know what that does. This would be a 6-3 pair. This digit wouldn't be a 3-6 pair then. Maybe it is finding out where the 3-6 pairs can lie in the puzzle. Because they're so much more constrained. And yet they're either here, most likely, and then not here and not here. And then probably here, but that's a very tentative probably. Or something else is happening and I don't get it. These black dots are very suggestively positioned looking at yellow and orange, aren't they? Well, I think they are. Oh, it's the non-consecutive constraint. I'm just not using it well at all. I'm failing to think of something very important that is going on. I feel that in my bones. I mean, you could look at the digit 5, which cannot be here. I think, because then it would have to be here. And then it would be in a circle because of being orange or yellow. Well, yeah, I think if 5 was here, it would have to be here. Can I say that 5 can never be in a circle? I mean, it's not a huge point, but this circle has 4 and 6 on it, so 5 on the line, so 5 can't be in the circle. This one will either have a 3-6 pair. Could it have digits from all below 5? A 2, a 4 and a 2. Yeah, actually, no, it couldn't, because this digit would then be either 2 or 4, but they would both be on the line, so not allowed. So it would be 8. And 4 and 2 would be on the line. You couldn't put 5 here. So 5 can never be yellow or orange. And therefore, 5 can't be pink, violet or red. And therefore, 5's in one of these cells. It's probably not a big advance, is it? Maybe if I could have confined it to those 3 cells, that would be something learnt. But since it could still be there, maybe that is nothing learnt. Okay, let's go back to thinking about this being 8, and that has to be 9. That's quite a strong requirement. This digit would be 2 or 3. 8 then would have to be in one of these two. No, not on this. I don't know. I'm really dying to find out something, and I'm utterly failing to do so. Greens. Greens can't be either of yellow or orange. So where are greens in the central column? They've got to be amongst these 4 cells. Oh, well that is interesting, because the greens are 2 of the digits from 2, 3, 4, 6, 8. We have these 4 cells available to hold them. Could that not be green? Maybe, I suppose, if they were in other digits here. Oh, okay, that didn't do it. Oh, there's something so basic, something so obvious. Something to do with the non-consecutive constraint. That's what's happening. That is what is happening. Why can't I see it? If this was 3, this is quite a difficult cell to fill, because this will be 6, and this wouldn't be allowed to be 2, 3, or 4, or 6. It would have to be 8. So if that was 6, 3, this would be 8, 4. Then we'd definitely have a 9 here. Then we couldn't put a 9 here, so we couldn't put an 8 here. So this would be 3. This would go 8, 4, something 4. Oh, there is that issue. I was looking for where 5 went in these cells. I didn't realise it couldn't go here because it would be next to 4 or 6. So 5 definitely goes in one of those 3 in the central box. That's sort of interesting. I'm just thinking about if you were to put 5 here, where do 4 and 6 go? In the central box, they would have to be amongst these cells. That couldn't be a 4 or 6. So in the plus shape, there'd be 1 there, probably 1 in one of these. I don't know, I just can't see my way through this. I can't see an opening move. 22 minutes. I haven't really gathered anything useful. Okay, I worked out that these two yellows are the same as violet. So this yellow digit does go in one of these cells. And then we have a group of 4 of 2, 3, 4, 6, 8. Now, that must include a 3, 6 pair. Because one of 3 or... Is that true, though? No, it's not. This could be 2, 4, 8. And then that digit could be 3 or 6. So that is not true. There can only be 1 8 on these two lines, maximum. There doesn't have to be any, but there can only be 1 8 on any of them. So, we know, if it was here, none of these digits could be 8. We'd have a 9 here, so we couldn't have a 9 here. That is the point. This would be 2 or 3. That doesn't do anything. 8, 4. This would be a 6, 3 pair, stopping that being 6 or 3, putting 6, 3 here. And this would be 3, wouldn't it, in that situation? Yeah, this is what to think about. Because this will break somehow. This being a 6, 3 pair seems very, very unlikely to me. This 3 would be the low digit on the line, which has 4, 6, and therefore would have to have 8 on it. And then this would be 9. So if this is a 6, 3 group, that is then the 9. And 8's on the line. And this is from 2, 4, or 8. It couldn't be 4, could it? No. This can never be 4 in the circle. That's quite an interesting thought. Because if it was 4, this black dot will either be a 3, 6 pair or have a 4 on it, and that would always break. So the circles can never have a 4 on. Yeah, that's interesting. That is interesting. This digit is 2, 3, 6, or 8. If it was a 3, 6, if it was a 3, that would have to be 6, and this would have to be a 4, 8 pair, and we'd have 9 here. And then this couldn't be 8, this would have to be a 3. Yeah, that would fit with this being a 4, 8 pair. Can't quite see what's going on here. I'm looking at a lot of the right bits, but I'm not putting the connections together. This can't be 5 because that would be sitting next to 4 or 6. I mean, that's quite interesting. That would have to be replicated there in red. This can't be 5 because it would be sitting next to 4 or 6. I don't know, it doesn't feel very strong, but something's happening there. Cells that can't be 5 already in the puzzle. I mean, there's a few. It's not really very helpful. No, that's not a point of attack. It's the circles, isn't it? Something about, oh. I kept saying if this was 8, that would be 9, and that breaks the non-consecutive rule. It's blindingly obvious. That's been available for 15 minutes. This can't be 8. This must be 3. There we go. So that's 6. Now I can put these in as 4s. That's an 8. And this is 2 or 8. Well, at least I've got some digits in the grid suddenly. Right. Well, if that's 2, this is high. 7, 8, or 9. If that's 8, well, then this has to be 1. It's not allowed to be 2 on the non-consecutive. I could wish that was more helpful. Now, 4 in this row is either here in green. Well, no, let's think about if green was a 3-6 pair. Oh, it can't be a 3-6 pair since we got that 3. So there is a 4 in it. Well, that's no help because we know where 4 goes in the plus now. It does mean there is a 4 in one of these cells. That's not powerful yet. Right. Something's happened. We need an 8. That has to be, I don't know, that could be 2 and going there, then this would be 8. Yeah, I don't know. I don't know that. Got to keep using, it was the non-consecutive. I was just missing a clear implication. This can't be 8 again, because then we'd need 9 on the line. It would be in the cell next to it. Can it be 4? Because one of these is 4 by Sudoku now. I feel like that matters. I could be wrong. If this was 4, this would be 2 or 8. Now, if it was 8, that would have to be 9. I don't know what that does. It doesn't seem to do anything. 4 sitting next to 3 or 5. 6 can't sit next to 5 or 7. 3 can't sit next to 2 or 4. Now, let's think about this pair. They definitely include 4, and in the central columns, that's one of them. The other one is 2 or 8, which has to be in one of these cells, so it's quite likely to be this. Can this really be 2 or 8? That would be 4. I cannot rule it out. Something's going on. Okay, can this be a 3-6 pair? By Sudoku, this would have to be 4, so it couldn't be next to the 3. So this would go 3, 6, 4. That would be 2 or 8. But this could still be 4 itself. I don't know. Okay, we worked out this couldn't be 5 because it would have to go there. And this can't be 5. That is not a big deal in terms of 5s. No, that's not it. Right. It's about this pair. Or is it about this pair and where they go in the central box? If that was a 3-6 pair, 3 would have to be either here or here in the central box. 6 would be somewhere here. This digit would not be 3, 6, 4, or 8. This would be 2 or 4. No, it would be 4. It would be going 3, 6, 4. I can't work out the ramifications. Okay, but we've done something at least. Surely I can convert this into real action. These purple digits, which are the same as these two, they cannot contain an 8 now because of this 8. So 8 is not a candidate for that cell. If this is from the 2-4 family, it's a 2. That would be 4. This would definitely be a high digit, at least 7. And if that was a 2, this would be 8. If that was 8, 4, 8 and 4 would have to be in these cells. Well, 4 already is. 8 easily can be. Hang on. These violet and red digits are the same as these 4 digits. That's a thought that I have not had previously. Not in that way, anyway. They're the same as those 4 digits. And they include 8. What else must they include? They must include this digit in one of those two, this digit in one of those two. So this in one of these 4 and that also. No, I don't know. It's not advancing my thinking. Let's go back to, if this is 2, that's 8. Then 2 is in one of these cells. In fact, 2 then is in one of these 2 cells. Yeah, these have to include 4. I don't know. Ah, goodness, I'm really straining and struggling with this. I think there's, just as the last step was not hard, it just had to be, the right question had to be asked. I'm sure that's going to be true about the next step when I eventually see it. But what is it? What is it? This has come down to 2, 3, or 6, so I can eliminate 8 from there. We said only one of these lines could have an 8. Now the only position that could occur is here, and this digit would be 9. And that would be 4, and this would have to be 6 and 3. We have 3, 6, 4, 9 here. 8 in this box would have to be in one of those cells, and that would make this a 2, 4 pair. What was this founded off if that was a 2? No, it was founded off if that was an 8. That's where I was beginning the idea. The trouble is, ruling that out doesn't really do anything. Ruling it in would be great because it would put a 9 here, and I feel like that would be something definitely learnt. But ruling it out, not so good. Okay, we know there's a 4 in one of these cells. We know that above all things. I just don't see anything to go on. It's so annoying. can 3 ever be in a circle? 6 would be... Oh, well, it wouldn't know. If 3 was in this, if 3 was in that circle, 6 would be on the line. Yeah, we already know 5's in one of those cells, don't we? Didn't we work out 5 couldn't be here or here for some reason? I'm sure there was a reason. Why couldn't 5 be in those cells? Wasn't there a reason? There was a reason 5 couldn't be here, because then it would be here. So maybe I have not come up with a reason why that couldn't be 5 and one of these be 5. This one would force this pair to be a 2-3 pair. Then we would need 1 in the circle. It would be next to 3. That would be 6, 2, and this would be impossible. So that doesn't work. So 5 can't be there. So I think 5's now in one of those cells. But if 5 was there, it would be here. I'm also pondering 3 actually as being in one of those cells, not touching the 4 again. But maybe it's much more plausible for 3 to be in one of these, although that would then have a 4 on. Oh, I'm so slow. I'm so slow, so painfully not on top of this. 3, 8, 4. This can't be 5. If that was 5, there has to be a 5 in the plus. Oh yeah, that may have been it. We worked out it couldn't be in the circle. That's why I know it's in one of these cells, and therefore not in violet, and therefore not here. Okay, I'd forgotten that, but that is true. That is what I've worked out. So 5's in one of those cells. Now, so the next question is, can 3 really be in a circle? If it was in this one, this digit would be a 6. There'd be a 4 on here. This would have to be high. I don't know. There's no reason why not. And maybe even this could be a 3. No, I don't think it could, because if that was a 2 or a 3, you couldn't put anything on the line. If that was a 6, you could only put 4's and 5's on the line. Oh, maybe this is the absolute key thing. Can this be low? If this was a 1, that would have to be a 6. These digits would have to only use 2, 3, or 4. That would have to be a 2-4 pair. Oh, with that being a 6, oh, that wouldn't work. That's really interesting. It's quite difficult to see. Let me explain why you couldn't put a low digit 1 here. And hopefully the others will just eliminate very quickly. If you were to put a low digit 1 here, this couldn't be 2 or 3, or there are just not enough digits you can put on the line. That would be 6. That would be next to 3 on the line. But this pair would have to all fit between 1 and 6. That would be a 2-4 pair. But you would have a consecutive issue here. 3 would be next to 4 or 2. So this digit can't be a 1. Now, for this to be low and be a 2, again, we'd have to assume that would be a 6. These would all have to be 3 and 4, and you can't do a black dot pair. 3 is too close to 6. This cannot be low. This has to be a higher digit than anything appearing on the line. Now, that means this is the low digit. Now, this has either got a 4 or a 3 on this black dot. So this low digit has to undershoot those. Let's assume we could try and get a 3 here. This would have to be a 4-8 pair, and that would force this digit to be a 9. Yeah, that does just work. If this was a 2, again, we have to keep, well, this one would be a 4. This now couldn't be 2 or 4. It could be 6 or 8. And this would be 3 or 4. And now this could be 7, 8 or 9. So this is 7, 8 or 9. And both of these are going to have to find a berth in violet and red somewhere. In fact, all of these 4 digits are the ones in violet and red. Oh, that means, since we know those 4 digits which stick out of the central box on the plus, just as these stick into it not on the plus, they're the same, and they don't include 5 or 6 definitely now. So 5 and 6 have to be in this bit of the plus and not touching each other. And the 5 not... So the central digit can be neither 5 nor 6 because it would touch the other one of 5 or 6. So these two include 5, and these 3 cells include 5 and 6. Now, that probably means something about 7. 7 can't go here because it will be touching 6. It can't go here, touching 8. I don't know. I was wondering, for 7 to be in a violet cell and touch, and not touch 6, it would have to sit opposite it by a knight's move. And then 7 in the circles would have to be here, if 7 was there in the middle, or 7, 6, 7 in the circles. So you'd have a pair of 7s. But there is an alternative, which is whacking 7 in here, or indeed in one of these cells. So no, that's not strong. It is getting interesting with the non-consecutive now. Now, if this was a 6-3 pair, we've got to have a 4 there then, haven't we? By Sudoku. I don't know what that means. Oh, it's so interesting. Right, if these were both high, that would be a 2 and would have to go in that cell. If that's high, this is a 2 and has to be there. Then we've got 1, 3, 7 and 9 to distribute in the top half of the box. It's already quite interesting about where 3 goes. Because it's either sharing these 3 cells with 5 and 6. And then it would have to avoid touching 2, which would be difficult. Or it's in one of these 2, and therefore one of these 2. And if it was in one of these 2, that would have to have a 4 in it. This couldn't be 3 or 4, it would be 2 or 6. can't get to grips. Oh, here's a weird thought. If this was 8, this digit would have to be 1. And this would be 8. So 8s would be in these positions. There'd be 1 there, 1 in those cells. Let's just keep thinking this through in case something occurs. No, I don't know. That is an interesting thought, but all it would do is eliminate 8 from this cell if it was incorrect. Now, these 2 greens have to go in this group. I mean, that looks all too easy at the moment. The other 2 from that group are sitting over here, aren't they? What does that do? Well, I mean, it would be very interesting if that was a 3. In this row, 3 would be in one of these cells. I've never thought of this before. That's quite interesting. If this was a 3, 3 would be in one of these cells. This would be a 4 and 2 or 8. This wouldn't be allowed to be 4 or 3 at that point. It also couldn't be 6, because that would need 3 here, and we just posited 3 there. So this would have to be a 2. That would be 4, 8. And 2 wouldn't work there with, right, there we go. 3 doesn't work in this cell. Because in this row, it can't be in the same region. It would have to be out here. That would make this pair have a 4 in it. That 3 would make this a 6 and stop this pair being a 3-6 pair. This would have to be 4 on top of 2. And 2 can't go on this line because it's below 3. So this digit can't be 3. That has to be 2. That has taken a lot of working out. But my goodness, it's there. It's available 50 minutes in now. And I might have just made the breakthrough. This digit is now 8. That 2 has to go in one of these cells by the law of leftovers thing with yellow versus violet. This can't be 2 or 4. Since 2's in one of those cells, none of these are 2. Come on, let's just crack on now. This is definitely high, we knew that. It's got to be above 6, we knew that. 2 can't touch 3. Wow. Does 3 have to be in one of these cells? Well, can it be in one of these cells? That would be 4, 8, and this would be 6. Oh, look, we got an 8 here. This digit is low. This is 1. That can't sit next to 2. Oh, that's quite interesting. Where is 1 in the central column? It's not in the plus shape. 1 in the central box has to be in one of the coloured cells. Oh, 4 can't sit next to 3, that's just the rule, so this can't be 6. So now 3 and 4 must be used in those 2 cells. Either this is a 3-6 pair with 4, or this is a 3 and that's a 4-8 pair. This digit can't be 3 or 4, by the way, because it's sitting next to 3 or 4. So now the 3-4 pair is sitting there. Now 3 can't be in those cells by Sudoku. It can't be in those 2 because they're next to 4. 3 has to be in one of these 2 cells, and 3, 5, 6 are now a triple. Now, remaining digits in this digit is 7 or 9, but it can't be 7 because that would be sitting next to a 6. So this is 9. These coloured digits are 1, 2, 7 in some order. That one's not 2. And the coloured digits in the central box are 1, 2, 7, 8, which equate to the circles, which have to be 1, 2, 8, and therefore 7 here. That digit now becomes a 6 on the between line. That's 3, that's 4, that's 8. Here we go. We're actually moving, finally. The 2 in this row is in one of those. No, it could be there. 7, 9, 1. Okay, if that was 6, would it be touching the 7? Not necessarily. It might well be, yeah, this 6 would be touching 7, so that's not 6. If that's 6, this is 7. Oh, this can't be 2 anymore because it's touching 3. So this is 2 now. Now this is a 1, 7 pair and they can't surround 6, but we've noticed that already. This can't be 3 because it's next to 2, so this is 3. Come on, come on. What about this? If it's 7, that's 5. That won't work. If that, in fact, we need a 1 in this row. It's that simple. This is 1, and that must go in the yellow cell. This is 7, and that must go in the orange cell. This can't be 3 because it would be next to 2, so 3 in the central column is there. This digit is 5 or 6, and the same as that one. And I can't see how to disambiguate those yet. Now, here, where are 4 and 8 in this row? They're in these 2 green cells, which really don't need to be green anymore. They haven't ever achieved anything in their greenness. These are from 2, 5, and 6. This one next to 7 can't be 6. This one next to 4 can't be 5. 1, 4, 8, 3. We need a 2 in this box. It's got to be here to avoid being next to the 3. Now, we need 6 and 7 in this box. Well, this is 5, 6, or 9 by Sudoku. Yeah, this is the kind of time when this non-consecutive rule actually starts helping rather than being utterly confusing. But let's hope that that occurs. One of these is an 8 by Sudoku. 1, 2, 4. One of these is a 7. That sort of thing stops this being 6, but actually that being 5 or 6 stops either of these being 5 or 6. So this digit, which can't be 1, 3, 4, 7 or 2, also can't be 5 or 6. It must be 8 or 9. Now this digit can't be 8 because it would be next to 9, and now this is where 8 is in the box. Now there's got to be a 2 in column 4 that's not next to 3, so it's in one of those cells. This can't be 9, so 9 can't be next to 8 here either. 6 can't be there or here, sitting next to a 7, so 6 is in one of those two. Okay, this one can't be 5 or 6 either, so let's try that over this side. Oh no, hang on, 2 and 9 are down here. This is 5 or 6, because it can't be 2 or 9. That's now a pair. This is a triple that consists of 3, 7 and 9. 3 can't be next to the 2. Other than that, not sure. These are from 1, 5, 6. We can't have 5 next to the 4 or 6 next to the 7. Come on, puzzle. Keep giving me information, because I prefer it when you do. This is 5, 7 or 9. So 6, I was going to say it can't go there, but that could be 9. This would be 5. That would sort out the 8, 4. And we'd have a 7. Okay, 6 can't be here, because it would be touching 7. That's not great. I'd rather prove 6 can't be here, actually. I don't know. Okay, what's this? This sees 4, 8, 6, 3, 7, 2. This is 1, 5 or 9. This one sees 6, 3, 7, 8, 4. So 1, 2, 5 or 9. That doesn't really do anything. I've never managed to use these black dots in the corners. That can't be 2 now by Sudoku. Why are they not helping more? Why am I not using them more? Oh, look at this. 6, 4, 2, 8. But this is touching 6 and 8, so it can't be 5 or 7. Or 9. So that's definitely 1 or 3. What about this? 6, 3, 7, 8. But again, can't be 9 or 5. So 1, 2 or 4. We've done the between lines. They're just done. We've done all the coloured cells that I was trying to do earlier. They're all done. Bye-bye colours. So the rest of it is non-consecutive with a little bit of black dottage. But it's hard. It's still hard, isn't it? 2. One of those is a 2. If this was 5, that would be 2. These would be 1, 6, 9. The 6 would have to be here. Right. If 6 is there, fine, that's where 6 is. If that's 2, that's 5. And then 6 can't sit in either of these cells next to 5 or 7. So one of these two is definitely a 6. That means one of these two is a 6 by Sudoku. And if it's in the corner, then we get to place 3. As if 6 is there, 3's in the corner, and 3 has to be here to avoid being next to 2. But if 6 is there, there's 4. Oh, this can't be 4. So if this is from the 2, 4, 8 family, this is 4 sitting next to 6. I don't know. I don't know. What about this? This sees all the even digits, and it can't be 1 or 3. So 5, 7 or 9. This one, why haven't I pencil marked this? 8, 4, 6, 3, 7, 1. It's not allowed to be 9. This is 2 or 5. That feels a little constrained, doesn't it? 8, 4, 1, 3, 7. This isn't allowed to be 2. So 5, 6 or 9. That's an annoying grouping. This isn't allowed to be 6. So 2, 5 or 9. Now 5 and 6 are not allowed to be next to each other here, but one of them's over here along with a 1. Yeah, that's just not going to happen. Oh, I said 6 was in one of those cells earlier, and therefore this digit isn't 6. So we found the 6 in box 7, and that does put 3 in the corner. That's 3 in the corner. That's 3 in the spotlight, giving me one other 3. And putting a 3 somewhere up here. And somewhere up here. And that's really not getting the job done on 3s, is it? But we got a digit. We got this 6. And this 3. And now 2 can't be in any of these cells. It must be in one of those. 3, 6. If, well, yeah, if this was 4, then 4 would have to go here in box 7. I don't know what that would do. Oh, goodness me. Something has been squeezed out, but it turned out not to be much. 4, 8, 3, 7, 6. This is not 2. This is 1, 5 or 9. Is there some non-consecutive business going on? Oh, I haven't. No, I mean the cages, I have done those. Once I did these pairs, I've done the cages. Oh, that's so annoying. They're completed. So I'm really just looking for non-consecutives now. I finished that black dot. I haven't finished this one. Right, so why couldn't this have a 4 on it? There is an interesting point, at least, that we'd have an X-wing on 4s, at least. In fact, if that was 2-4, we'd have an X-wing on 4s and 2s, and that would be 2-4. If that was 4-8, we'd have an X-wing on 4s and 8s, and that would be 4-8. So if there's a 4 on that, no, this can't be 3, and the corner can't be 6. But if there's a 4 on here, we're going to get a 2-4 or 4-8 pair down here. Don't quite know what that does. Feels like it might do something, but I can't see it. I'm probably missing a blindingly obvious move based on non-consecutive now. This can't be 6. I did probably say this earlier because it would be next to either 5 or 7. So 6 in the box is in one of those two cells. If it was there, 5 and 7 would have to be kept here and here. So if that was a 6, we'd have 7 here, 5 here, 8 here, not next to 5, 4 here, and 9 here. Oh, what did I just say? 6, this doesn't work. 6 there, 7 there, 5 here, 9 here, and this digit couldn't be 4 because of 5 or 8 because of 9, so that's not 6. This is the 6 in the box. And now 6 is not here. This is a 1, 5, 9 triple, and I can fill in 6 and 2 over this side. This can't be a 1 touching the 2. This can't be a 5 touching the 6. Okay, and these are a 5, 7, 9 triple. And if we knew which of these was 4 and which of these was 8, that would help slightly. Okay, but again, it's progress. It's teased out. It's not easy, but it's progress. This can't be 5. So the 5 in the row is in one of these cells. That's not a power move. Ah, goodness me, it's not. 3, 6, 7. Oh gosh, 5 is not in either of these cells either. I mean, this was hard, but at least there was something to focus on. Okay, this can't be 6 anymore, so now this can't be 3 in the corner. That's a big deal. That means there is a 4 on this, which is definitely putting 4 in column 7 there. But also there's either an 8 X-wing or a 2 X-wing. So these are selected from 2, 4, 8 now. And one of them's a 4. And there's definitely a 4 in one of those cells. So now there's a 4 in one of these two. And that cannot be here because it would be touching 3. Aha! So this digit is a 4. And that's not touching 3, so 3's not there. So I have got my 3's a bit limited in these top 3 rows, but not actually usefully. Never mind. It's good, it's all good. Something is happening now. 4, 8 pair in the final column. And a 2, and 2 digits from 5, 7, 9. Right, 6 has to be in one of these two, along with 3. They're a 3, 6 pair. And these include 1 in one cell, and the other one is from 579. And one of these is from 579, and one of them is from 2. One of them is from 2 or 8. We know 2 can't go there. Oh, if that, oh look, 6 there is telling us about the 3-6 pair. Not in a good way, because I wanted this to be 3 so I could find out what that was. But 6 there is sorting out the 5s and the 6s, which have been sitting in the middle for far too long. That gives me 1 6 down here. Take 6 out of this cell. Got a 2 5 9 triple here. Do I know more about them? No. But I've got this 1, so that's placing me a 1 in box 9. One of these 3 cells is a 1. 6 3. We need a 1 in this box as well. It's in one of those 2. So 2 can't be in those cells. Or touching the 1. Is that any use? No. 2's in one of these 3, I think. So if that was a 1, this would be a 2. Oh, look, 3 is looking at that cell, so that's a 1, and that's sorted out all the 3's, hasn't it? 3's were just dying to be sorted out. That 1 now does place this 1 here, and that can't sit next to 2. So those are both 4-8 pairs, and this is now a 4-8 pair. And the exciting thing about that is I get to place 2 down there. Everything else in the box is from 5 7 9. This bottom one is not 7 by Sudoku. Right, now 4 8 1 6 3. We've got 2 to place, not next to 1, so, and not there, so it's got to be here. And of course our favourite 5 7 9 trio. That can't be 5. In this row we still need 2, and we can put that in, not next to 3. We've got an 8 to place, and that's got to be here. And that can't be 7 or 5. This is 9, and that might actually start us on the trail of disambiguating 5s, 7s and 9s. Look, it's beginning to happen. It's beginning to happen. That's not 9. Okay, it's probably stopping happening. But 9 is also looking at these 2. We've got 1 2 5 8 to find homes for down here. This digit at the bottom can't be 1 2, and it's next to 6, so it can't be 5, and it must be 8. This is now 2 or 5, but this can't be 1, or it would be touching 2. So this is 1, and it's not allowed to touch 2. And now we finally see when this non-consecutive actually does really help. It finally happens at this stage. That's 4, that's 8, can't be next to 7. So this box is done. That's a 5, 9, 7, 5, 7. Now 4 and 8 are resolved by the 9 and 5 above them. And here we have 9 and 5 as well. And in this column we need 9 and 4. And in this column we need 1 and 7. And I hope there are no consecutives left. Is this it? No, I do not get a tick. I've got something wrong. I can't believe it. What's wrong? There must be a consecutive pair somewhere, and I've done something wrong in the process. Or I've got a wrong black dot or something. All the black dots look good. All the cages look good. All the between lines look good. So, is there any chance of fixing whatever consecutive pair I've got wrong? Those are the ones. Is one of them touching a 2? No. Is one of the 2s touching a 3? No. Is one of the 3s touching a 4? Yes, there it is. Look at that. Is that the only one? Oh, look, I've put this digit in wrong. It's a 5. This might be the solution, guys. I'm going to change that 4 to a 5. It's just a mistype. And there we go. The solution is correct. That is an incredibly difficult puzzle, Joran. I mean, I don't think any of the steps I did find were not the next step. I think they were the next step, but I just think they were hard to isolate. And I'm very impressed, but oh goodness, it's hard. The non-consecutive constraint and how it interacts in some ways can be very difficult to find, but well done if you got through that quicker. Certainly that first step that took me 15 minutes or whatever it was, where 8 wasn't allowed to be next to 9, I should have been better at that. After that, I think this was tough. Thanks for watching. I've enjoyed myself, and you get to watch me enjoy myself. I hope that's worth something to you, and I'll see you again next time on Cracking the Cryptic. Bye for now.